so Luis Cobucci is going to be on the stage. This is his second lecture in this conference, and in this talk he will be presenting JSON Web Tokens as an alternative for smart and self-contained tokens. Luis, here you go.
Thank you. Hello. Are you enjoying the conference so far? Yeah, good. So, the presentation that we're going to do now is essentially based on my experience from 3 or 4 years ago. And the idea here is to explain you how we simplified the life that we simplified all the problems we were having in an API by using JSON Web Tokens. Who of you creates APIs? Can I? Wow, that's a lot of people. That's cool. Have you ever? So if you do that, it means that you deal with tokens. But what exactly are tokens? Essentially, tokens are something that identifies something else. And we are very familiar with that in a basic application that we do. For example, we have a browser client-server application that talks to a database server. Usually, when you do authentications, you send a request saying, this is my email, this is my password, and you're getting something back from that. But before getting something back from the server goes there and say, hey, the credentials that you're sending me are actually valid, or they're not valid, and I will go and give you the proper response. If everything is good, I would say 200, okay, and this is your cookie. Here on the session ID, this is the identifier. This is a token. It identifies the session that you're handling on the server side and gives you something to send on the next request. So when you're sending the next request, you're going to say, this cookie has this value, and this is my token. Therefore, the server knows, hey, you're John. Hello, John. But this is not really how APIs work, right? You have to be stateless. Stateless means that every time you send the request, you have all the information there, and the server doesn't need to go to something else to fetch that data. About this time that I sent, so 3 or 4 years ago, I had a mission. My mission was to create an API, and the plan was very clear. We were going to store all the authentication tokens into the database. That was a very common practice back then. So you can imagine, every time someone logged in, I was giving an identifier with pointing to a specific user, with an expiration and a certain scopes that allow the token to be used. Every time you have a new request, a new token, and a new token, and a new token, and a new token. You can imagine that it was wonderful, right? Everything was so complicated, and every time we had to check if the token was valid or not, we had to hit the database to retrieve the information and check, does this this token is still valid, or is which user is pointing to? And you can see that the mess that we had was huge. Every token was in the database, so we have to have some sort of tools or background jobs to clean up the database, to remove the expired tokens. And I was really, really happy, right? Obviously not. I felt the need to have like something really simpler. That's what I needed. And back then, I didn't find that. So I had to search a lot. My name is Luis Cobucci. I work in Amsterdam now at Usabilla. And during my research back then, 3 or 4 years ago, I found this thing called Jose, or José, how you want to call, whatever, which means JSON object signing and encryption. And it's a set of different specs. So we have JSON Web Signatures, JSON Web Algorithms, JSON Web Keys, JSON Web Tokens, and JSON Web Encryption. Today we're going to talk about JSON Web Tokens, how they work, how they look like, and what you can do with that. So with no further delay, I'm going to show you a token. This is a JSON Web Token. If you just look at that, you can see that it's very similar to something that you already know. It looks like base64 encoding, right? Where you have all the characters there. It's a binary safe representation for something. But there are some dots there. And dots are not part of the allowed characters in base64 encoding. The dots here serve as separators in the JSON Web Tokens. So if we just break the line to have something simpler, we will see that we have two different parts. These parts are they're not really encoded with base64, but rather base64 URL. That is just a variation of base64, and it changes some characters to make them URL safe, which means that any string encoded with base64 URL can be passed into a query string or a cookie or a post request, and everything will just work. To encode that in using PHP, it's pretty simple. You do a normal base64 encoding and then modify the characters, removing the padding, which is the equal sign. To decode that, it's just the reverse operation. You calculate the remainder to add the padding, and then change the strings and add the remainder, the padding. So now that we know how to encode and decode this information, let's apply the algorithm. By doing base64 decoding on these 2 bits of strings, you'll see this. And then you find, finally, we have a JSON. These 2 different things, they have very specific meaning for JSON Web Tokens. But you can see that inside of the token, we can put any information. And that's really powerful when you're doing any kind of things. And this means that the token itself is self-contained, which means you have something that scales horizontally as well when you're doing different kind of things. The first and the most common use case is authentication, where you have the client of your API, and that communicates to a database. So instead of doing just a post request and changing that for a simple token, we're going to do that using JSON Web Tokens. The authorization request is essentially the same. We will have a validation, but here we're going to add some information in the token. So I'm going to say that my API, which is auth.example.com, is the issuer of the token. And that token is permitted to this specific client. And it will expire in 300 seconds. Once that token gets issued, we will give a response back. And that response is essentially like this. So we're not necessarily setting cookies anymore. We're just giving back a token. And this is a very simple way to authenticate using JSON Web Tokens. You can make it more complex according to your needs. On the next request, you send the token, obviously. But now in the authorization header, where you're going to send, hey, bearer and the token that you just got back from the API. And the API will check, is this token valid? Can it be used by this client that is performing the request? What is the issuer of the token, does it match with my expectations? And can it be used right now? So is it expired or anything like that? This is a very basic scheme. and for authentication. And people started to speak like, okay, can we do that with OAuth 2? Are you familiar with OAuth 2? If you are, you know that the access token is usually an opaque token, right? And we can just change that and use a JSON Web Token there. And you have something self-contained in the OAuth 2 part. If you look at Auth0, for example, they're using JWT together with OAuth 2. The League of Extraordinary Packages, they have a OAuth 2 server where you can choose if you want an opaque string or a JSON Web Token as access token. OpenID Connect is also another standard on top of OAuth 2. And that standard defines how you can interact with some specific things. So instead of putting user information inside of the access token, you put information into the OpenID token. So you have a very tiny token for handling access and the other for authorization. So it's very flexible and you can use for anything. Another example is handling sessions. The common way to handle sessions in PHP or any other language is essentially this. You have a web server where when you generate a response with a session, it will store a file. That file has the data of the session. And here, when we get, the client says, hey, give me, process this request, and this is my session ID. The web server will go there and read the file, get the session data, and perform the operation. This is very simple when you have just one web server. But when you have a load balancer in front of many different web servers, this gets a bit more tricky because the load balancer will do probably a round robin, which means the first request goes to the first web server, then the second goes to the second, and so it goes. And when you're using a file system as session storage, you have different files. And you don't have necessarily a shared storage with all the web servers. You can solve this with different things and different ways. Removing the session from the storage from the web server and putting it into a cache like Redis, or using sticky sessions on the load balancer so that when the client performs the request to the web server, it will always go to the same web server, but you can also use a JSON Web Token. The JSON Web Token will have the data, so everything that you have in a session can go in the token, and you can have that as a cookie. And you will have essentially the same thing, but this will scale horizontally, and regardless of how many web servers you have, you don't need to do a lot of I/O to read things or do a connection to go to Redis or memcached. But this has some problems, let's say that. You have to be very smart to not put any private information, because base 64 is not encryption. It's just an encoding. Anyone can just decode the token and read the information that you have. And that is not really only relevant for sessions. For anything that you're using the token, you have to be aware that you're not storing things in a private way. The way that we create tokens make it difficult to invalidate sessions, because everything that if you create the token once, it will be there and it will be available for all the servers to the expiration. So you don't have necessarily a way to store the reference to the token. We're going to talk about token revocation afterwards, but that's something that in this specific context, it makes it harder to do proper session handling with security in your mind. So these are all things that you have to consider. A token can get very, very big, and a cookie has some limits regarding the size, so you have to think. But if you really want to try that, there are libraries for that. This is a library that Kremius and we just wrote together during a conference in Brazil, and it does the work very nicely. If you want more use cases, you can think of anything that can be stored and represented as a token to identify something. You probably already created things like password recovery tokens, right? Where the user goes there, hey, I don't remember my password again, so please send me an email, and I click there, go to web page, and then I'm gonna create a new password for myself. Usually, these things expire. So the token that identifies this password recovery request could be a JSON Web Token, and you have in the token already the amount of time where the token needs it will leave for, right? So you will know when to expire, and you don't need to have any database connection for that. Another use case is for promo codes, where you have a limited set amount of codes. You just send these codes, and you will use it. You can do that if you want to go very crazy and just try it out. If you have a very automated home, so you have your door lock is automated. You don't have keys anymore. You can use some sort of tags. So using RFIDs as protocol to communicate with the tag and the lock, you can use a JSON Web Token and write it to the key so that when you just put it close to the lock, it opens the door based on the configuration you have in the token, based on expiration. You can go crazy of all the possibilities you have. But how does it really work? Essentially, the anatomy of a JSON Web Token looks like that. You have two parts, the headers, and they define it's essentially metadata about the token itself. You have things like, this is a JSON Web Token, the algorithm that was used is, in this case, none, and you can put more information here, which is not really relevant to your application, but how the parser should interpret the token and decode it and use it. And you have the claims. The claims are the place where you put all the information you need to add. As we said before, they are represented in this way. You have a base64 URL algorithm that encodes the headers, a dot, the same for the claims, and another dot. So again, this becomes this. But since we're using base64 URL to encode and decode the token, it means that anyone can modify. So can we trust that things remains the same, nobody modified the token? For that, to ensure the integrity of the token, we use signatures. So the payload of the token, which means the header, a dot, and the claims, without the last dot, we use this as a payload for a signature algorithm. And that also gets encoded using base64 URL, and you put after the last dot. So that's why we have this last dot in the JSON Web Token. If we want to do a very basic and naive implementation of a library to create JSON Web Tokens, this is the code. You can see that it's definitely not complex at all. You receive an array for the headers, another for the claims, a string that you're going to use to sign the payload. Then you just encode everything. You create a signature, encode the signature, and concatenate the payload plus the signature. Fairly simple. But this is using a very specific algorithm. This algorithm is the HMAC SHA-256. Do we have more algorithms? Yes, we do. So for signature, we have this list of algorithms. And the specs about the algorithms that you can use to sign a JSON Web Tokens, they give you some recommendations. And the first library, the first algorithm that we have there in green, it is mandatory for all implementations. The ones in gray, they are optional, and the ones in orange and yellow, they are really recommended. So it's nice to have, and the RFC, they say, hey, please use it because it's more secure than just HMAC. For the most common use cases, I would recommend you to use RSA. Why is that? RSA is compatible with many different providers. So you have RSA when you're using OpenSSL, and you have implementations in Java, JavaScript, and many other languages that knows how to deal with private and public keys in this specific algorithm. The others are not usually, well, HMAC is fairly simple. ECDSA is not always available. But do you know the difference between HMAC and RSA? No? Yes? So HMAC is a symmetric algorithm. It means that you use the same key to do the verification and the creation of the signature. So if you create a token and sign it using HMAC, you have this very same key, which means that using that across different implementations, or even if you have a JavaScript and a PHP client, and a PHP server and a JavaScript client, the JavaScript client needs to validate the token and ensure that it's getting a token from a trusted place. If we're using HMAC, the key needs to be known by the JavaScript client. And we all know that JavaScript is not something secure. We cannot trust on that. Not because of the language, but because it's available on the browser, so anyone can just read the code and get the key. And then they can just create tokens using your key. And your servers will just say, hey, this is a very nice token. This is not what we want. So for that, we use asymmetric algorithms like RSA or a CDSA. And they use public and private keys. So to create the tokens and sign them, we use the private key. And to validate that, we use the public keys. Since the public keys are public, we can just put it anywhere available on the web, and people can just read it and use it and validate the tokens that we're using. So for that specific case where you have non-trusted clients validating your tokens, an asymmetric algorithm is more appropriate. So applying that to the tokens or the example that we have, and using HMAC here, will be the token. So we have headers, claims, and signature. Now, if anyone modifies the token, the signature will not match. And then we'll see, hey, this token is not valid, please don't send me it again. But how much data can we put inside of a token? That's a very important context, a very important thing to remind, because if we put too much information, the claim here, the size of the claim will increase. It's just base64 encoding, essentially. And the signature will also increase. And if we're using that as an HTTP header, we have to be aware that if you have mobile clients, this will affect the performance of the mobile app, right? So not putting too much data is really important. We have some predefined claims, which we call the registered claims. These are very important for the whole Jose and JWT ecosystem because they have specific meanings. And you should not use, for example, the first one is JSON token ID. You shouldn't, this identifies uniquely the token that you're issuing. So if you create a token with ID 1, you should not have another token with the same ID. And you shouldn't use JTI as a claim for different meanings. So going from top to bottom on the left, we have the JSON token identifier. We have the issuer, which identifies via a string or in a URI, what's the issuer of the claim, the token. The audience can be an array or a single string, and it defines who is the audience of this token. This can be interpreted as what is the client that can use a token, or what is the list of services that you can access with that specific token. The subject means what exactly this token is about. So if we're dealing with authentication, for example, the subject will be possibly the ID of the user, or if you want to just use the same string and then put the user ID as a claim, you can do that. So the subject will be user or authenticated user, something like that. The last, these items, it's very important to say that these are case sensitive. So when you're comparing the expectation and the information you have on your token, they should match only in this. The case sensitivity should be respected. We have on the left, on the right, sorry, the list of tokens, the claims that are related to dates. So the first is when the token was issued, so issued at. The second is expiration, when the token should expire. And the last is related to the minimum amount of time that the token can be used, so it's not before. With these three claims, you can do things like, hey, the token was issued now, it will expire in an hour, but it is only valid after 5 minutes from now. So you can have a lot of control over the token that you're issuing. But as I said, once the token was issued, you cannot go back in time and say, hey, this is not there, because it's all stateless. How can we deal with revocations? Using the private claims, so let's say we have these private claims, and using the register claims that we just said, we can identify the token, and we can know exactly what is when the token expires. So using something to store some kind of information, you can revoke the token and put that validation as the validation of the token you receive in your application. So we have essentially two strategies to handle revocation. One is blacklisting. Blacklisting works in this particular way. Let's say that you're dealing with a token with this ID, and you want to say that this token is no longer valid. You simply add this ID to the blacklist, and when you receive the token, you try to match the ID to all the blacklisted tokens. Using Redis or any kind of cache system, you can add a time to leave for the row. So by getting the information about the expiration, you can define the TTL of the entry. Therefore, the blacklist will be cleaned automatically. Every time the token expires, you have the TTL there. So the validation will go, hey, is the token blacklisted? No, we're good. Is it still valid based on the date, the signature? Yes. All right. If the token is blacklisted, you can bypass the signature verification or any kind of complicated verification because the token is blacklisted. We have the second strategy, which is whitelisting. This works a bit differently. So every time you issue a token, and that's very useful if you need to put information related to, if you want to keep track of all tokens that were issued for a specific user. So then when you're removing the user, you're gonna revoke all the tokens that he or she got, right? So every time you create a issue, you issue a token, you're gonna add it to the whitelist. Possibly, depending on your needs, you're gonna say the token with this specific ID issued for this specific user. And depending on the storage system you're using, you can use wildcards to fetch that and remove from the whitelist. And you will also add the information about the expiration. So every time you add it, you will validate a token, you'll check, hey, is this token whitelisted? Yes, so we're good. If the token is not whitelisted, it means that things are not good. And if you want to manage that, you just go to your Redis or to your database or whatever you want to store that information and remove the entry of one specific token or all the tokens related to a user. How can we do that and manage tokens using PHP? If you go to JWT.io, you'll find a very nice tool to see the content of a token. And if you scroll down, you'll find a list of libraries in different languages to use and create and verify tokens. When I started this project that I spoke of to you, I've created my own library because by that time, the libraries that we had were not really good. We had libraries using essentially one single static function to do all the things, creating the tokens, and another single static function to verify and validate the claim data. For me, this was not ideal in terms of design, so I created this library. Nowadays, I'm working on a new version of this library, which essentially solves some design problems that I've created on the past. And I think now we're almost done with the next major release. There are some few things that I need to finish, but it will be done shortly. How can you use this new version that I'm working on? So the first decision that you have to do is to choose between the symmetric and the asymmetric signature or algorithm. If you're going for a symmetric signature, it means that you have HMAC, so you have only the signature and only one key. For asymmetric, you have the private and the public key. And if you need, you can put the key password to be able to encode or actually sign the payload that you need. Once you've done that and created all this configuration for the way you're going to use the library, you simply get a builder and start to add data to the claims to the token. And afterwards, you just get a token, signing it with that specific key. Now, I'm just using a custom claim called UID with this version, this value 1. If I want to add the identifier, I just say, okay, the identification of the token that I want to issue is this one, a random string. And it was issued by me. And it's permitted to for this list of clients. And it was issued now, can only be used after 5 minutes from now, and will expire in an hour from now. This is using the asymmetric configuration that I just said, and the result of this operation is this. So you can see that using, and this was very, this was RSA 256, yes. And you can see the size of the payload and then the size of the signature is much bigger than HMAC thing. And just one object there. If we decode the headers and the claims, you will see this. And you have all the information that you used or defined there. You have the expiration, you have when the token was created and everything. And this can be represented using this new version of the library in microseconds precision. So if you have to validate in that precision, it's much easier. To parse the token, you can just use a parser. So you get the configuration and pass the string there. The result of that will be a token object where you can just read and perform all the operations on that. To validate the token, you have two options. But these two options, they work with a list of constraints. And that's one of the biggest difference from the previous version of this library. You can compose your validation with all the constraints you want, and you can also create customized constraints. So if you want to have custom data there and you want to check, for example, every token that I receive must have my private claim called user ID. And the value of this claim must be an integer. So you can put that as a validation constraint and just pass to the validator. We have the assert method, which will go through all the constraints and throw an exception if any one of these fails, but it will get all the results of the failures. So if you have 3 or 4 constraints failing, you will know that the reason of the failures. If you're dealing with just validation, you will see only a Boolean result. So it will either be true or false, and if the first fails, you won't go through everything. So in terms of performance, this is optimal. There is a lot of criticism regarding JSON Web Tokens. I don't know if you ever heard of this or saw on Hacker News or some blog posts saying, hey, don't use JSON Web Tokens ever again because it's a problematic standard. So the main point of the critic is that the set of algorithms is up for the user to choose. And some algorithms, like none, can be used. And people will think, hey, this is secure. But actually it's not, because you're not signing. Anyone can tamper your token, and your authentication will not work. One of the biggest flaws in the implementations of all the libraries was the fact that people were trusting on the header to get which algorithm you have to use to verify the token. And you know that you can never trust on client's data. If people can just modify the claim and the header, people can forge a new signature. So my response for that is be strict about the algorithms you're using to create a signature, and be strict when you validate that as well. So if your application is only dealing with RSA, just allow RSA and don't parse the token, get the algorithm from the header and try to do something about that. No, go straight with the algorithm you have. So to summarize everything, JSON Web Tokens are great for many things. They can be bad for many things depending on how you use them. So it's really up to you to make the right calls regarding which algorithms you're going to use, if you need to revoke things, when you're going to revoke things. The use cases we discussed, they are they vary a lot. So you have to think and apply them according to your needs. And obviously, there's no silver bullet. So you can use JSON Web Tokens, or you can use other, you can just use an opaque token if you need. But in my opinion, in experience, JSON Web Tokens are very helpful to simplify and make things more scalable on your software. My main use case nowadays is dealing with microservices. So I don't do any kind of validation in the service itself. I have that being handled by an API gateway. So this is done in a different language using the same algorithms, but this is connected directly to my Nginx as a plugin. So every time a connection gets hit to this API gateway to go the routing and go to my microservices, I already know that the token is valid or not. And so the services that are being handled there, they are always dealing with valid tokens. I hope this was really useful for you and created more knowledge around JSON Web Tokens. And thank you very much.
Okay, are there any questions for Mr. Lewis? Okay, here we go.
Hi.
Hi.
Thank you for a great talk. I was interested, you mentioned that servers should probably stick to a default algorithm and not trust the header. What about DOS vector attacks? For example, can a user repeatedly target the server with a huge payload and thus create a CPU throttling on a server and basically cause a downtime? What is the solution to that?
That is a very good question, and it really depends on your architecture. So in my use case, my API gateway is performing the validation of the signature and the verification of that. And as you pointed out, verifying the signature is kind of a CPU-heavy operation. So how to allow that, how to prevent this kind of attacks? My API gateway has rate limiting and throttling. So you will be able to identify that. If you don't have an API gateway and you're dealing directly with a server doing that, let me go back here. You can see that, as I said, this is my specific library, right? So you can, in this case, I put the signed with as the last constraint because it is CPU heavy. Therefore, if the token doesn't match with the issued or the audience or the validation regarding expiration, I won't get to the signature, right? So you have to understand how your libraries work to be able to avoid these things. But I really recommend to use rate limiting and throttling in this case.
Thank you.
Anybody else?
All right.
Okay.
Thank you very much again for being here. And I'll be around, so you have time for questions there.
Okay, thank you, Luis. You can catch Luis in the middle track. I'm just going to remind you, 700 hours here, Slobodan Stojanovic, and in track B, Michael Cullum. So please be here, 700 sharp. Thank you.